All right, I guess we can go ahead and get things started. Hello, everyone. Good morning, good afternoon, and good evening. Thank you for taking the time out of your day to join us for this webinar. My name is Allison Davis, and I'm the Campaigns Manager for Big Animal, EDB's cloud database offering. Today, we'll be learning about cloud high availability and your cloud availability options. So now, before I introduce you to our speakers, please note the Q&A button at the bottom of your Zoom window. If you have any questions about us about the presentation during the presentation, please feel free to ask us using that button, and we will have some time at the end to answer some of your questions. I would like to introduce today's speakers. Our first speaker is Ashleen Wright, Director of Product Management. And then our second speaker is Aaron Sontag, our Senior Software Development Engineer here at EDB. And I'm happy to have you both here.
Thanks very much.
Allison, thank you very much.
So before we kind of get started, I wanted to get started with a poll for everyone who's attending. And I kind of wanted to just gauge where everyone's at in terms of where your approximate uptime SLA targets are. So I'm going to go ahead and send a poll out to everyone who's in this webinar currently. And if you guys don't mind, just go ahead and answer that. We'll give you guys a few minutes to answer this question. What is the approximate uptime SLA you target for your applications? The poll is up, so please let me know. I'll give you guys a minute to answer. Awesome. The answers are coming in. I'm interested to see your guys' reaction to the answers. So I'm gonna give you guys just another 15 more seconds. Awesome. All right, guys, I'm going to go ahead and end that poll in just a moment here and share the results. So I'm going to go ahead and end that now and share the results with everyone. So it seems like it's almost a tie between 99% or less or 99.99%. Do you guys have any input on that, Ashley or Aaron?
Interesting. Actually, that actually feels a bit familiar with what I would expect, to be honest. I did expect probably a little bit more in the 99.99% threshold, but definitely curious as we go through this presentation today. We'll kind of talk through the range of different uptime SLA options, and I think it'll be awesome as you guys have questions, post them right in the chat and we can kind of dig into some of these things.
Awesome. All right.
Right. Yeah, I'd just like to say that I like the idea that I can kind of see that there's a good swath of folks that are have some room for improvement, let's say, and we can address some of that. And the stretch from 99 up to 3 nines, let's say, is something we can definitely help with. And then stretching from 4 nines up is also something we've got solutions for. So this is awesome.
Awesome. Well, thank you guys. All right. And over to you, Ashleen.
Great. All right. So let's get started. So today we're going to talk through kind of impacts of cloud high availability for your business. So from a really kind of high level perspective, one of the key things here is you don't really want to be caught flat-footed. You don't want to have to wait until a crisis happens. You want to be prepared ahead of that. Largely because a lot of you are probably running pretty critical applications from a business perspective, and downtime can be really costly. This example specifically from Gartner is an estimate in terms of every minute of downtime can cost, on average, $5,600 per minute. So that's obviously impactful when you're dealing with, for example, a pretty large, availability zone failure or regional failure. So today we're going to actually walk through some of the concepts in terms of framing high availability, and then we'll dig into some examples. And ultimately hope to give you a great idea around what EDB can help you with, and also how can Big Animal, EDB's cloud offering, address maybe some of your concerns or pain points. So stepping back for a minute, thinking about availability in the cloud, and one of the things it's obviously a little bit different when you're actually looking at it from an on-premises perspective. So from a cloud standpoint, there's a few different vectors I like to think about when looking at high availability. So one is from an application or business perspective, like what are the needs that you have there? So how critical is the app to your business? How long can you sort of withhold an outage and manage your business with an outage or not? And then on the flip side, around support. So, what kind of support and SLAs are you expecting from a vendor? What kind of support and SLAs do you have to uphold to your end customers? And then third is what type of resilience you're looking for. This ties into kind of infrastructure and regional resilience. So, for example, from a cloud standpoint, you've got maybe instances running on AWS. On the flip side, you're also thinking about types of failures that you want to mitigate around dealing with a networking issue, a storage failure. And how do you ensure that your database is resilient in the face of those types of failures? And even more broadly, like when you're looking at a regional perspective, how do you mitigate against a hopefully not very common, but potentially possible regional level failure? What plans do you have in place to make sure your business is protected? So I like to think about these questions. We'll dig into a lot of different concepts today to actually walk through different options and considerations for them going forward. All right, so let me share a little bit of context around EDB's cloud offering, Big Animal. So the reason I'm going to do so today is actually kind of walk through those availability considerations in the context of how can EDB help? So EDB Big Animal, just to give you a general overview, is our fully managed cloud database service. We are currently available on AWS and Azure, with GCP coming soon. We offer a multitude of different deployment options for you. Customers can provision PostgreSQL. You can also provision EDB Postgres Advanced Server with Oracle compatibility, for example, if you're looking to migrate off of Oracle. And we also offer a range of high availability options, whether it be in a single region, whether it be across regions. So we'll dig into a lot of that today, and we'll really talk through a lot of the components around how backup and restore really fit into some of the capabilities around what we offer for disaster recovery and options like that. All right, so one of the key factors here is, what are some of the core reasons of, why customers are looking at Big Animal, why you should consider a Big Animal as an option. So one of the things that I think is kind of important is that, EDB has been a leading provider of Postgres for over 15 years. And with Big Animal, we're bringing a lot of that expertise to the forefront in the cloud. So we are building on a deep breadth of Postgres expertise and incorporating that in the product as well. For example, with things like advanced tuning capabilities with EDB Tuner from a performance standpoint, as well as providing compatibility with Oracle, coupled with the fact that we have deep Postgres experience. We've also been helping customers for 15 years move off of legacy databases onto Postgres. And most notably, compatibility with Oracle to help customers migrate off Oracle. And third is we provide a range of availability options. So today we'll kind of walk you through what's available and what sets us apart as well. And lastly, I'd mentioned that we're currently available on AWS and Azure, with GCP coming soon. So from a customer standpoint, you get the cloud of your choice. We're not restricting that in any which way, and really looking to facilitate kind of your workloads wherever you might be running. All right, so today we're really going to dig into availability options. Now, before we really get into some specific examples, we're going to walk through what I tend to like to start conversations with when looking at high availability. So I tend to think about it from a business criticality standpoint. I think it's helpful because it helps to really frame like what types of failures you want to mitigate against. So there's obviously varying ways of how to define business criticality. For today's session, we're going to kind of talk through 3 areas. One is around non-mission critical applications. So this could be, pre-production, internal apps. For example, you might have like an internal HR application for a subset of users that, doesn't necessarily need always on capability at all times. So, that's a consideration, a very valid use case. Moving beyond that, there's obviously kind of the next layer of more mission critical apps where, for example, you could have profit and loss impact to your business. There could be a very tangible revenue impact if these types of apps go down. They could be customer facing, and you're really kind of stepping back, thinking a bit more broadly. How do we mitigate against these types of things? And then third is around probably the utmost criticality in terms of like applications that absolutely cannot withstand downtime, whether it be, cross-cutting revenue critical apps. Personally, I like to think about the stock market. This is kind of a notorious example where downtime is extremely costly in those types of examples. In addition, like payments processing, you're directly losing revenue when you're experiencing downtime for those types of applications. So today we're going to actually walk through some examples of apps that fit into these categories and the types of failures that can happen and how do you mitigate against them. All right, so we're going to kind of talk through from top to bottom, starting with non-mission critical and then really working our way down into kind of the most critical scenarios. All right, so with that, I'll start from the top. For the folks who actually answered on the poll with kind of uptime SLAs of 99% or lower, you might be running a slew of different kind of internal applications or non-mission critical apps. And there are a few options that we'll walk through today that EDB provides, as well as like what types of failures can you actually mitigate with these types of apps. So starting with non-mission critical, one of our core architectural options on Big Animal is sort of your traditional single node Postgres cluster. And one of the key things here to note from an EDB perspective, we offer an uptime SLA of 99.5%. Typically we see customers looking at their dev or test, again, that lower tier type of application threshold. There's no built-in failover, for example. However, in terms of an architectural perspective, you've got that single primary, but you still do have some failure resiliency. So I'll kind of walk through an example in a few moments around what that looks like with HA. Now, with a single node architecture, this really kind of aims at addressing those internal types of apps, and EDB provides backup and restore options. So that is kind of one mitigating factor around those. But a lot of times when you start to look at like uptime requirements from the business that really tend to lend themselves more into that higher uptime SLA. So for example, we're talking 99.5 and greater, 99.99% availability, where you don't have as much leeway for downtime. And we have a few different considerations here in terms of what we're going to look at and what type of failure scenarios we can mitigate against. So I'll contrast this in a minute to a standard sort of single node architecture. So here's kind of on the left a higher level view of standard high availability cluster for Postgres on Big Animal. So you got a single primary with a single standby replica here. Big Animal provides you the ability to configure an additional standby replica as well. And in contrast to what we just looked at with single node, one of the things here, sort of key differences, is that we have automatic failover capability. And one of the benefits here is that EDB is providing kind of automatic detection, automatic failover for these clusters within a single region. Each node is also spread across availability zones as well. So we'll kind of talk through that a little bit more in a moment. But one question I tend to get a lot of is, what is RTO? What does ERPO look like? So just to sort of step back for a second, RTO is recovery time objective. How long does it take you to recover from that failure? RPO, recovery point objective. What's the potential data loss that you're going to experience? So from a kind of a standard high availability perspective, our RTO is around 35 to 60 seconds. And then RPO around 0. So we automatically default to synchronous replication on these types of clusters. And with Big Animal, we have built-in point-in-time recovery as well. So that kind of gives you a sense of sort of the parameters around these types of clusters. But you might be asking, well, what types of failures can I really prevent here? So just to kind of give you a little bit of a sense, one of the core key failures that you can really mitigate against here is like a disk, a compute, or a network failure. Now, why is that? Well, when you're looking at the cluster setup with single primary and 1 to 2 standby replicas, because of the replication with the physical streaming replication happening across the cluster, in the event of a failure like those, we're automatically detecting that and failing over to a new replica. So that new replica is becoming the new primary, and all of those incoming connections are going to be routed to that new primary. And then, in terms of like, well, what happens after the fact? So that old primary is going to be rejoining the cluster as an additional replica after the recovery moment. So this example here is really around helping to mitigate against things like, network errors that you might face, the disk storage or disk errors, and compute. I did see someone actually raise their hand. Allison, I'm not sure if we can take people off mute to ask questions, but
So that person did put their hand down, but if I
Okay.
see the hand raiser, I'm going to have people type out their questions. Worst case scenario, we can address it at the end. But yeah, if we have anything during the presentation and you guys raise your hand, I will request that you guys just type it out. We'll answer it for you.
yes,
Yep,
totally
and
feel free.
we'll be watching the Q&A. So raising your hand is equivalent to just posting something in the Q&A, and we want to answer these questions in line. So please ask questions.
Do not hesitate. All right. Moving kind of beyond the scope of like a disk, a computer network failure, you might be looking at different cloud offerings today or adopting, AWS, Microsoft, GCP. Commonplace, all of the major CSPs have availability zones within regions. And from an application perspective, you want to look at, well, how do you mitigate the failure from an availability zone perspective? So if one availability zone goes down, how do you ensure that your application and database is resilient? So with Big Animal, our clusters are automatically spanning availability zones within a single region, meaning we're actually provisioning different node replicas in different availability zones. So in the event of an AZ going down, one of the unaffected replicas can actually become promoted to the new primary. And then those client connections are going to be routed to that respective new primary as well. One other consideration that I like to kind of think through is, all that we just kind of went through is, okay, you've got a single node architecture as an option. You can feasibly do a backup and restore to mitigate it, but against database failures. You've got standard high availability that helps you mitigate against disk or compute or AZ failures. But what about ensuring that you can recover from a disaster? So what do we have that's available for you to ensure recovery in the event of an entire region going down? So we'll talk through one of our core EDB offerings called Postgres Distributed in a few minutes. But what I'll walk you through right now is an additional option for standard high availability clusters or even single node clusters. So we have something called Faraway replicas, similar in notion to read replicas. So from a technical perspective, customers get a few benefits here. One is you can get benefit from disaster recovery. So you can kind of have a disaster recovery plan in place across regions. Second is you actually get the added benefit of being able to serve read traffic to kind of a subset of local users as well. I'm going to pause here for a second because I see I have a question. All right, so let me just kind of talk through this for a second, and I'll answer it. So one of the questions is, do we need a separate license to do auto failover, or the standby servers read only or read write? Okay, so Roman, I will actually kind of talk through the second half of that question when we get to Postgres Distributed. But in terms of auto failover, from a pricing perspective, let me just give you an example. So this architecture on the left, this picture here is what you would kind of equate to that prior drawing, standard high availability. And you'll see here there's two standbys and a single primary. From a cost pricing standpoint, we don't have what I'll call like an added cost for auto failover. However, from an EDB perspective, what you're paying is a per core price for the database. So if you think about this example here with Postgres across 3 AZs, let's for simplicity purposes say you've got 4 cores running on the primary, 4 on the standby, 4 on the other standby. So EDB in that example would be charging you the per core price for the total amount of cores you've provisioned. So the failover itself is automatically managed by us. What you would be paying for as an end user is around the total core consumption. So that's a per core price times total amount of cores that you have. In this example that I'm showing here is the example of a faraway replica. So I had mentioned previously, this accepts read traffic. So these are read only. So for example, in the right-hand side here, let's kind of envision a scenario where you might have like a business intelligence team on the West Coast, and you want to make sure that you can actually serve up the data to them to be able to read from. So in this example here, it's a read-only standby replica, and you cannot write to it. However, in a few minutes, we'll kind of talk through a different architecture that is more in line with multi-writer capability. For this example, we have read-only, but for the architecture we'll shift to in a minute, we'll kind of talk through the write capabilities there. So to give a little bit more context, in the event of a disaster, what this actually enables you to do is you could have, for example, region A and region B, where you have that standby replica in a completely separate region, and you're mitigating the failure in the event of region A, experiencing a disaster.
Right, and I think, Ashley, what I want to mention here is just the idea, especially for those 3 nines or Tuni's customers, they could look at this solution as a way to prepare for disaster recovery by allowing them to deploy their current application stack in 2 locations without concern for kind of the operational impacts of that, but
Exactly.
be able to depend on the back end to support that failover case.
Exactly. Yep. Now, one of the things that I have talked with a lot of different like users and end customers around is, what does that failure scenario look like? So, in the event of an entire region going down, how do we handle the failure? And then subsequently, how do we handle the recovery? So we give customers the ability to provision kind of an unlimited number of replicas for your clusters and in any kind of supported region. And faraway replicas can be used to serve that read traffic. But in the event of a regional failure, what you can do is actually manually promote the replica in that sort of region B example, and that can become its own cluster. So for example, you can enable that for high availability and continue to operate your business using that cluster. Often, and I would say in general, like a lot of times where I see gaps, like competitively too, it's like a lot of folks don't actually talk about, well, what about the recovery back to my original region, right? Like region B wasn't really where we are intending to operate most of our business out of. So from a recovery standpoint, I think it's important to note, if you're looking at a scenario where you want to recover back to the original region, similar type of structure, we actually recommend provisioning a new faraway replica into that original region. And then what you can do is promote that and enable it for high availability to sort of ensure that like recoverability back to your original state. All right, so this next topic is one that personally I find definitely a bit more exciting in terms of the art of possibility. And I think for a few reasons, but one of the things that's pretty compelling is, what we'll kind of talk through next is really some uniqueness in terms of what DDB provides in the market. And we went through, non-mission critical applications and then sort of shifting gears a bit towards options around mission critical. Well, now taking that a step further, we're going to walk through different applications where you really are looking at near zero downtime. And I think in most scenarios, people would sort of step back and say, of course, yeah, that's what I want for my business. And I think one of the things that in our vision from an EDB perspective is we really want to make this accessible to as many customers as possible. So we're going to kind of talk through one of our newer preview capabilities on Big Animal using extreme high availability. So EDB had made an acquisition a few years ago for a company called Second Quadrant. And one of the sort of core pieces of technology from Second Quadrant is EDB Postgres distributed. And this provides the underlying foundation for us around architectures to really withstand any kind of failure scenario. And what I'll kind of walk through are some of the high level benefits, for you to consider. And then I'll have Aaron kind of talk through kind of a simulation example here on the architecture, just in terms of basics of how it's structured and set up and achieves these benefits. So just stepping back for a second, with this type of architecture, one of the things that we're providing is increased application resiliency for unplanned outages. Doesn't matter if it's a storage, compute, AZ failure, regional failure. This covers resiliency in all of those types of unplanned outages. Second is it's built using geo-distributed architecture with multi-writer capability. So, if you are looking at the ability, for example, to have geo-distributed workload, for example, you might be like Central US, East US, and you want to be able to actually, one, segment that data logically, serving kind of both user bases. But like one of the challenges is you don't really want to have to deal with advanced conflict handling when you're writing data to multiple locations. This is where like some of the benefits here from a Postgres distributed come in, because we handle that for you. There's advanced capability in terms of being able to enable customers to run geo-distributed workloads and handle that level of conflict handling. The other major benefit, which is going to be coming soon this year, is around online major version upgrades. And this is something that, is a pain point for so many people when you're looking at a database upgrade. It's painful. It incurs downtime, not desired downtime. This is where Postgres distributed comes in, because it has capability to really enable that online. So minimal disruption to your end users. I'm going to pause for a second. And
I think go ahead. I think you have a question. All right, so one of the questions I just got right now is how does EDB Postgres distributed differ from Aurora global databases?
Oh, interesting. Okay, that's a great question. So if folks are familiar with AWS Aurora, there's two variants, I'll call it. So there's MySQL and PostgreSQL. And focusing on Postgres, we actually differ from Aurora global databases with this second benefit here. So Aurora global databases, you can provision across regions. However, those replicas per se, those global databases in multiple regions are not multi-writer. They do have that capability for MySQL. They don't have that capability for Postgres. And with Postgres distributed, you not only get the cross-region durability, but you're also getting the ability to run geo-distributed workloads that can accept reads and writes. Thanks, Allison.
Of course, awesome, thank you.
So I'm going to hand it over to Aaron for a second. Just a high-level talk through this architecture here for a minute in terms of how it's set up and how we typically handle some of these failure scenarios.
Sure. So the first thing you could look at is within a region, what's happening in case of tolerance of failures. And you want to look at how you're tolerating different levels of failures, whether you're tolerating a node failure or a region failure, as Ashley was just discussing. And so if you think back to like the levels of failures that we discussed till now, then within this diagram, within a region, if a particular node fails, what PGD does is make sure that we can recover, or the recovery time objective is very low for any particular region. But then also in case a region fails, then the recovery time objective for a region failure is very low. And this is accomplished by replication of the data between the nodes. So you have in each region, single database writer, and that is the lead in the upper left of each region. And that lead in each region is able to accept writes, and Postgres distributed reconciles those that write activity dynamically across the regions. And then you set the replication rule set and commit behaviors that you want to see. And, we're aiming for defaults of synchronous behavior. And so synchronous behavior would mean that data would be written into region A, and the application layer would not get a confirmation of that write until the lead in region A could confirm that a node in region B had also been able to commit that write. And so that's how we accomplish a very low recovery point objective as well. So RTO in terms of failure recovery and RPO in terms of data integrity are both greatly enhanced through this solution.
Thanks, Aaron. I just see as well that we got another question. So this question is, during upgrades, will backward compatibility be taken care of before decommissioning or upgrading a particular version? So around kind of those online major version upgrades, there's two factors here. So there's disruption from kind of like your end users and your user base. And then there's like the compatibility from a database perspective. So just to kind of give you a sense with an example, let's say you're looking at, going from Postgres 14 to Postgres 15, introducing that new major version. One of the sort of key tenets around the compatibility is really more so focused on the core database itself. So for example, with open source Postgres, there is not backwards compatibility going from like 14 to 15, for example. And by and large, from a community standpoint, like when you're signaling those major versions, that is in effect kind of a difference in compatibility between the major versions. What benefit we're providing is around the disruption and mitigating the disruption. So typically, like during that upgrade process and the compatibility side of things, like there's a period of testing that you still want to ensure still doing before the actual upgrade happens around the core database tech itself. But then the benefit of Postgres distributed is really around during the upgrade process, making sure that, for example, when you're switching over to 14 to 15, that mitigation of the disrupting the end user base is really the benefit that Postgres distributed provides. All right, and then I've got another, this is a good one. Another question. What's the purpose of having 3 nodes in a single region? Usually for DR scenarios, 2 plus 2 is the widely used solution. How does the lead of that particular region is decided? Let me actually touch on that first comment for a second, and Aaron, I'll let you talk through this as well. But
Sure.
Benefit of 3, I'll give you kind of straight up answer is if you really come back to sort of core consensus algorithms. So if you take a look at like the Raft consensus algorithm, one of the sort of higher level principles is around achieving quorum. And having quorum implies that you have an odd number of nodes. And in terms of 3 in general, one of the benefits is having an odd number helps to achieve that consensus. Now, in a single region, like why you would want 3 versus 2 kind of ties back into that. But I've definitely seen where it's single region, not Postgres distributed. It's totally a trade-off discussion. Like a lot of customers do 2 nodes in a single region, not for Postgres distributed, but for kind of standard high availability. And that's totally valid, totally applicable. The advantage of having 3 though, with standard HA is that you can set one of the nodes to synchronous, and you can set the other to asynchronous. So you're having that like level of consensus and honestly like assurance from an availability perspective that you're like mitigating performance impact and mitigating data loss as well. Now I am going to have Aaron talk through like how the lead of a particular region though is decided. If you want to chat through that, Aaron.
Sure. So I'd say that you touched on what I was first thinking of here is definitely the fact that it allows us to have 3 nodes, allows us to set 1 synchronous and 1 asynchronous within the cluster, so that if you have 2 nodes and the 2 nodes have a synchronous relationship and one of them goes down, then you're no longer able to write spontaneously at that point, because your application is written to the lead. Let's take this example in region A. Your application is written to the lead, and the lead is saying, within my region, I have a rule that I will not allow this write to complete until I've replicated that synchronously to another node in my region. And if I only have 2 and one of those goes down, let's say even for a normal maintenance period, then I'm no longer going to be able to do that right. Whereas with 3 nodes, either of the two can behave as that synchronous confirmation. And so if we do maintenance on one of the 3 nodes, you've not interrupted your synchronous replication. This pattern, by the way, is not unique to PGD. This pattern is also a key component of our HA solution. So that is why I generally recommend the high availability solution for big animal with a 3-node configuration within a single region as opposed to 2. So that pattern exists both in HA and this extreme high availability solution. And then the other part, as you mentioned, Ashleen, the other reason that we have 3 nodes is for quorum. An election. So if and when, let's say, the lead node fails, the rest of the cluster has to make a decision as to elect the next leader, and that is an automatic process. And so an odd number of nodes is a good start, so that the 2 remaining nodes know that the third is down, and they can make a decision as to who is the next lead. And that concept of an odd and a minimum of 3 exists not only within a region, but as you can see, exists across regions. So that is why there's region A, B, and there's a region C. We haven't really talked about that much, but there's the witness down below. And in this architecture, the witness is not handling any data replication. It's a little hard to see here, but there's kind of 2 types of lines that you're seeing. The solid lines and the dashed lines. So the solid line, you should understand, is including both data replication and consensus relationships. So these are data replication relationships and consensus relationships. Whereas the witness down below, you can see is got a different line. Those are only consensus relationships. And so the witness in that third region is providing that rule of 3 minimum odd objects, both so we can maintain that both at the single region level and a multi-region level. The other thing I just want to mention is that there's 2 lines across the center here, and really what's happening is that's just an easy way of or a simplified way of representing the fact that all of these nodes are actually all of the data nodes kind of in the region A and B are completely enmeshed in data replication and potential consensus relationships.
Thank you, Aaron. So kind of shifting back a bit. So we kind of talked through the architecture, some examples. Now, just to get a little bit more specific around the benefits, like how does this extreme high availability option with Postgres distributed differ, right, from like standard high availability, or like what's the advantage of that? And I generally would say that this, in general, when you're looking at it from a kind of higher level perspective, in the event of regional failures, this is a fantastic option because, as Aaron just mentioned too, the data is getting replicated across regions automatically. And therefore, by design, it's resilient for zone regional failures because of the globally distributed nature of it. But even more broadly, one of the things that I would say in general is enacting a DR plan in real time is a little bit nerve-wracking. So if that DR plan is not exercised, frequently, is not tested frequently, do you really know that it's going to work? And I think that's a huge, impactful decision for a business. But with Postgres distributed, the data is already getting replicated across regions. In effect, you're automatically already enacting kind of disaster recovery. I almost think about it as like on a daily basis, you're already prepared in the event of a disaster. And I think that's one of the huge benefits that comes with it, is like the level of assurance that you're getting in those types of failure scenarios. So I'm going to share kind of this summary slide, and then we'll share just kind of like final thoughts. This gives you sort of like a table level view of all the different options that we covered today and different use cases. So, high level, Big Animal from EDB provides a variety of different options to mitigate against these types of failures. So whether you're running non-mission critical apps, mission critical, or absolutely essential, regardless of the scenario, we've got solutions from EDB available. And this kind of lays out the different options here. So we've got that use case. So for example, the standalone Postgres cluster. We've got mission critical apps with high availability clusters and disaster recovery capabilities with Faraway replicas. And then kind of more broadly, we have Postgres distributed, which really enables high availability and a disaster recovery plan as well. This kind of walks through kind of like the regional implications. So we've got, that single node, which is in a single region. Customers are mitigated against failures for high availability within a single region, but optionally, you can provision Faraway replicas to get that, failure mitigation for an entire region going down. And then with Postgres distributed, you get the benefit of all of that together. So from a solution standpoint, kind of we talked through a single server setup, multiple standby replicas with a standard high availability, Faraway replicas as an optional capability. And then we've got Postgres distributed with the true kind of active capability across regions. And then from a failure perspective, when you're looking at non-mission critical apps, you can do kind of a backup and restore to ensure kind of database failures. Mission critical apps, you're looking at mitigating its availability zone failures, subsequently regional failures with Faraway replicas. And then lastly, with Postgres distributed, again, you're kind of mitigating all of that. And then lastly, like the RPO and RTO considerations. I think people generally like to kind of ask so they get a sense for their business, like what the impact's going to look like. And from an RTO and RPO perspective, you can see that there's variability based on the type of use case. You've got all the way on the right, sort of a 0 RTO target and 0 RPO target for Postgres distributed, based on kind of that active architecture. And then with standard high availability, you have different considerations based on the architecture. So if you're looking at a single region, you've got that failover recovery time of 35 to 60 seconds with an RPO of around 0 for that failover due to the inherent nature of how those backups are actually set up. And then on the Faraway replica, that recovery time can be kind of workload dependent, I'd say. With the RPO typically less than 5 minutes based on where the threshold is being set. And then for single nodes, similarly, like you're looking at the RTO is definitely workload dependent. You're not necessarily getting that automatic failover. And then from an RPO perspective, it's dependent on the backup, right? So the latest that point in time recovery was taken, again, could be 5 minutes or less in that scenario. And then from an SLA perspective, we have various options. So starting with 99.5 up to 4 nines, and then 4.5 nines is actually something that's sort of a sneak preview, but will be coming out with Postgres distributed when we are generally available. So one of the things I wanted to share today with you all is take Big Animal for a spin, try it out. Here's the link to register. And I'll go back so you guys can see that link, but I really appreciate all the questions, interaction today. And I'm going to actually have Allison give one last closing comment.
Yeah, so actually, before we get the closing comments, we do have one more question, and that is, what are the benefits of Postgres distributed above and beyond standard high availability?
Oh, awesome. Okay. So from
Ashley,
yeah, go
while
ahead.
you're going through that, can you go back to that slide that has the table
Yes.
of all the different offerings? Yeah, that's great for reference.
Yep, perfect. So kind of the two key benefits I would say is that you've got I kind of like to think about it in terms of the RTO and RPO, partially because you're in effect achieving higher availability. So you have more resiliency with Postgres distributed than you would with sort of standard high availability. And then second is you've got multi-writer capability, where with standard high availability, like you can read from other nodes, but you're not able to write data to multiple nodes. And I think one of the things that I sort of tangentially talked about is like enacting a DR plan that's not tested frequently is a little nerve-wracking. With Postgres distributed, it sort of takes the guesswork out of that.
Yeah, I just want to also add to this, this table is a great representation of what customers could be looking at if they're at that 2 nines and trying to stretch up, or the 4 nines and trying to stretch up, and kind of a general guidance for improving your availability. Is to choose components that have an equal or greater SLA than your target for your entire solution. And what Big Animal does that's most exciting to me is it eases the access to some of the more advanced or the next level up database architectures. So even for 2 nines or 3 nines solutions, the idea that you can quickly provision and, as Ashley says, practice a Big Animal restore by at any point in time practicing that restore process and against a new database with very little additional work in terms of infrastructure and spin up is very powerful, or practicing disaster recovery. And so the idea also that you can improve your SLA by practice, but not only practice, but also working towards multi-cluster configurations. So you have your application cluster in one site. You can deploy a more advanced Big Animal Postgres solution on the back end, and that more advanced solution can support your working towards a higher overall solution SLA. And so the key here, I would say, is that with PGD at the most extreme end, is that if you consider you have an active application cluster for your solution in a particular region, PGD can make it so that you can become active in 2 different locations, thereby potentially distributing your application cluster traffic across 2 different locations. But even if you're in that transition, it's not like a day 1 transition, let's say, even during across that transition, it makes that whole process of evolving and improving your SLA so much more tolerable and achievable when you can rely on a back-end solution that is already where you want to be, that is already active, or at the next step.
Yep, 100% agree. We do have one additional question. Is this only offered as database as a service, or is it also offered for other cloud offerings like platform as a service or infrastructure as a service? So with EDB, we actually offer kind of a range of different options. So Big Animal is offered as database as a service. And then I typically equate that from a cloud perspective. So from traditional comparison, if you're looking at AWS or Microsoft, their PaaS offerings like RDS or Azure Flex Server are considered PaaS. And similarly, I would consider Big Animal under that PaaS umbrella in terms of the layers of what we manage, what the customer is responsible for. And then we also offer the ability to run EDB software in a self-managed environment like infrastructure as a service. So we offer a multitude of different environments. And I think that's one of the benefits of actually coming with EDB, is that you've got that the core benefits of the technology across either public cloud, your own cloud, self-managed, or fully managed.
There's another question here about blue-green deployments, and I think that's a great case for the highest availability solution, the Postgres distributed extreme HA, where with it being multi-writer, the key here is that, again, it's active at the foundation and multi-writer, and so it does naturally support a practice of a blue-green operations rollout for updates. So that is a fantastic question.
All right, so it seems like we are at the end of our webinar. I want to leave you guys with a few things. So after this webinar ends, we will be providing a survey. It should open up automatically at the end of this webinar. We have some awesome stuff in the works here at Big Animal. And if you're interested in like being one of the first to know some of the stuff we have coming out in June, there will be a input box so you can say that you're interested, and we'll reach out to you, and you can get like a first look. But other than that, I want to thank everyone for attending and thank our speakers, Ashleen and Aaron, for speaking on this topic. And if you guys have any additional questions that you're like, hey, I just thought about this after the webinar, please feel free to reach out. We will be sending a copy of this webinar and the slides to each and every one of you. You guys can either respond directly to that email, or you can email me personally at allison.davis@enterprisedb.com, and that is allison.davis@enterprisedb.com. But otherwise, I just want to say thank you all for attending, and I hope you guys have a great rest of your day, afternoon, evening, and we hope to hear from you guys soon. So thank you, everyone.
Thank you.
Thanks, everyone.
Yes, thank you very much.